and worked in the field of AI in medicine. Apart from this, he is appreciated for his commendable contributions in IIT BHU and truly known for his academician skill. Professor Ravi Bhushan Misra is currently working as a professor emeritus in CSE department NIT Patna. Before this, he worked as professor in Hague scale in CSE department at IIT BHU. He earned his PhD in the field of AI in medicine. He has more than 40 years of teaching and research experience. During his career, he carried out various administrative responsibilities. He obtained the prestigious INSA fellowship for his short-term visit to the University of Bath, England in 1997. He also obtained certificate of merit by the Institution of Engineers India, Computer Division in 1995. He has completed many sponsored research projects funded by AICT. He published 127 journals and 124 conference paper. Under his guidance, 16 students got their PhD degree. He has supervised 51 MTech students. His research areas include AI, cognitive computing, and computational bioinformatics. Now, I would like to invite to say a few words. Sir, your words of motivation are quite essential for our participants. We would be delighted with your expertise and knowledge in every way of possible. So without consuming any more time, I would like to call upon Professor R.B. Misra sir to enlighten us with his few words of true wisdom. Thank you, sir. Sir, please.
हेलो, आवाज आ रही है? हेलो,
Yes, sir. आ रही है sir आवाज.
ठीक है, ओके, then I'm going to start with you. So thank you, Dr. Choudhary, for inviting me this on this very occasion, and dear participants. What I am going to talk today is the three aspects are there. One is that AI, artificial intelligence. Second aspect is data science, and third aspect is the application in healthcare. Due to time limit, other constraints are there. I will just give a glimpse of all these three aspects one by one. So first I will start with you the AI methods and expert systems. What are the expert systems and AI methodology first of all? Just let me slide.
सर वॉइस इज नॉट ऑडिबल सर।
आवाज जा रहा है हमारा? हेलो,
नहीं नहीं आ रहा है सर।
अभी तो जा रहा था। हेलो,
जी सर नहीं आ रहा है आवाज सर, अब आ रहा है सर।
आ रहा है?
जी सर।
ओके फाइन। जस्ट उसको स्लाइड शेयर कर रहे हैं। स्लाइड शेयर होगा कहाँ पे होगा? स्लाइड दिख रहा है? स्लाइड दिख रहा है आपको?
नहीं
हेलो,
नहीं सर, स्लाइड अभी शेयर नहीं हुआ है सर।
स्लाइड शेयर नहीं हुआ है। अच्छा ठीक है। ये तो मेरा ये आइडिया है। मेरा शेयर वाला कहाँ गया जी इसमें?
सर अभी
स्क्रीन
नहीं
दिख
हुआ।
रहा है?
हाँ सर, स्लाइड शेयर नहीं हुआ है। आपका आवाज आ रहा है और सब ठीक है, बट
यानी
स्लाइड नहीं
वो
दिख रहा।
स्लाइड वाला जो ऑप्शन है
सर वो
वो
वाला होगा सर, एरो जो ऊपर उठा हुआ है।
एरो
जी
वही तो
सर,
नहीं
उसी को क्लिक
दिख।
करना है सर।
ये हैंड दिखाया जा रहा
जी सर, जी
है।
सर। एरो जो, हाँ, एरो वाले को क्लिक करना है सर।
एरो वाला ही नहीं दिखाई दे रहा है ना। एक मिनट, मोर मोर ऑप्शन।
राइट से तीसरा बटन होगा।
इसमें जो है ना, ये नया से खुल गया कैमरा। पहला वाला तो ये है, एक मिनट देख लीजिए। पहला जो है माइक्रोफोन लेफ्ट से, समझे? दूसरा है ये कैमरा। थर्ड वाला कह रहा है
हम्म।
टर्न ऑन।
तीसरा सर, चौथा, हाँ तो कुछ पूछना है। पांचवा वाला है सर, एरो, प्रेजेंट
ओ
नाउ।
हाँ, तो प्रेजेंट नाउ।
जी सर।
प्रेजेंट में योर इंटायर स्क्रीन,
जी
इसमें कुछ
सर।
दबाना है का? इंटायर विंडो। नाउ दूसरा कुछ आ गया। शेयर का कुछ है नहीं था।
ये सर शेयर हो गया है, स्लाइड पर अब क्लिक करना होगा।
हाँ, स्लाइड, हम स्लाइड जा रहे हैं।
जी सर।
ये आ रहा है स्लाइड। हेलो, हेलो,
सर जी सर, स्लाइड अभी दिख नहीं
दिख
रहा
रहा
है
है?
सर। देखते हैं, अभी तो नहीं आया सर।
स्क्रीन पर तो आ गया हमारे। फिर से शेयर करना पड़ेगा। हमें तो दिख रहा है। अभी आपको को नहीं दिख रहा है? आर यू एबल
स्लाइड,
टू सी इट?
स्लाइड नहीं दिख रहा है सर अभी तो।
एक बार फिर से शेयर करते हैं। तो
जी
ऐसा
सर।
है, हम बोल दे रहे हैं क्या? कुछ होगा टाइम बेकार लॉस।
जी सर, जी
ठीक है।
सर, 15-20 मिनट। यस सर।
हाँ, बोल दे रहे हैं और बाद में आप लोग स्लाइड भेज देंगे।
जी सर, जी
ठीक
सर,
है।
थैंक यू सर।
तो हाँ, तो व्हाट वी आर गोइंग टू टॉक, artificial intelligence expert systems. So first of all, there are certain areas. There are three dimension structure of AI. One is the logic, x direction में, then cognition. अच्छा, एक मिनट रुकिए, आई विल जस्ट ट्राई फॉर 2 मिनट्स। अगर शेयर हो जाता है ठीक, अदरवाइज आई स्टॉप शेयर। हेलो, अभी कुछ दिखाई दे रहा है? हेलो,
हाँ सर, दिख रहा है सर।
हाँ तो ठीक है. So this
जी
is the
सर।
three-dimensional morphology of AI. So what you are going to see that in this first A. So three dimension and the x direction, y direction, and the x direction is a basic concept from where AI has been formed. There's a logic where philosophy, then cognition is cognitive psychology, and then computation, theory of computation from computer science. So there are three disciplines where the concept from AI has been derived. And what has been done basically, knowledge representation, how knowledge representation, then your reasoning, and then interface, human computer interface. So, and the third is your application, vision, then you have the utterance, speech, what you talk, and then you have robotics motor. That is, sorry, three fundamental and basic applications of AI. So next slide is that here you show that what are the chronological development of AI. Start from the 1956. It is said that in 1956, in the Dartmouth University, that is the USA, some stalwarts of AI, Feigenbaum from Stanford University, Michael Minsky from MIT, then Granter was there. So they people thought, so there are some ideas were there, where what to put the name of the such concepts. So there are two names were come out. One is the rationality, another was AI. So finally, anonymously, AI was taken considered as the name suggested for this all these concepts which are going around in the intelligent computing. So from there, first of all, the 52 Samuel developed a that is chess development. Then go McCarthy developed this. Then you go to take a develop a knowledge, engineering knowledge, formal level logic, and common theorem, proving theorem there, geometry. So you can see the chronologically the list is much more. So you have the developed important theory, learning theory developed by Winston, natural language understanding, Vinogard, and all these things were there. ANN was, I will say, Rumhelt and Hinton, that they developed the AI theory, artificial neural networks. So these are the things we were developed one by one, then came to the important was rational. So that is this when AI concepts are there, ANN there. So you can see from there, up to 2000, that is the blue chip, all these things were developed, and the haptic semantic wave, all these things were developed. Haptic means when you feel that somebody is touching to you. Now the robots are developed in this area. So some of the areas we have developed, and then you have applications are there. We're not going to much more applications there. So this is the basic structure of a knowledge-based system is there. There's a working knowledge-based, working memory, and the inference engine. So when you interact with computer work with the user work, then process is there, then working memory, some dynamic data is stored, and then inference, knowledge-based facts and figures, and then inflection is there. So what actually then is very so there are expert systems were there. Expert system was the one of the product of AI concepts and methodology which got the market in the user. So there were three levels that a small, a large size, a small size, a middle size, and large size. So there were three knowledge cell in this. These are expert system cell. Cell in this sense, it is not specialized. It is a general expression is there, and depending upon your problem, you cast your problem according to the format of the expert system cell. So ART is automatic reasoning system, knowledge engineering. There are 5 expert systems are there, and we have said there are 3 main components of AI. One is knowledge representation, where the rule-based systems is So different CRL railway system developed. Then your inference, how the reasoning is done. That is a reasoning, a backward chaining, forward chaining, all inheritance. So depending upon which of the system is there, they deploy their reasoning methods. And last one is truth maintenance system is of course very important. Is, so the, so they go for the then you go for the hardware interface, that is whether you do PC or larger scale computer, LMI Explorer, or a small medium size. Then you go developer interface, what is the editing, all the things, and user interface is more important in the sense whether you want natural language processing or you want your what is called audio processing, or you want speech processing, all these things as it is done in the robotics. Because robotics gives some command, it process and then do the work. So the AI methodology is there already, expert system. Then second is the all these expert systems are there and they are different sizes, means they are basically implemented on mini computers, or whether mainframe is the large size, mini or micro, mini is this mid size, and the small size is computers are expert systems are cell are implemented on this here, what is called PC and all these things. So this is what I said. This system is there. Anyway, so coming to the next slide, that is your yes. This one of the you can see very interesting. It's a slide here. अच्छा, ये एक्चुअली आर यू एबल टू सी दिस पेपर? हेलो, दिखाई दे रहा है जी? हेलो
सर दिखाई दे रहा है सर, दिखाई दे रहा है।
एक मिनट इसको थोड़ा बड़ा करेगा एक मिनट। So what I am interested to show here, देखिए ये डायग्राम जो है, व्हाट दिस डायग्राम शोज, इसमें जो है what I am interested to show this diagram. This diagram says 6 techniques of AI that is developed, and nowadays they are there. One is sorry. अभी देखिए, what is this? There are 6 techniques of AI topic research. One is expert system, that this gives the development from 1980 to 2000. What are the developments are there? The black line shows the average. Then heuristics, and then is the list, that is the development is there. and then is this other is this a logic-based approaches, and then machine learning. That's machine learning, one of the important. It is growing nowadays. 2020, it is going up to that, and then it is the, of course, planning and selling is coming down. So you can see one of the machine learning methods is going up, and one by one. Then there is some topics asked for the yeah, 6 topics. AI topics are conventional AI, games and video games, health and medicine, and knowledge management, logistics and transport. See, one of the important, what is this topic of the FDP there? There is health and medicine. So AI is inclusively application in health and medicine. So that's what I have to show this by this slide. Then next we are moving to the data science. So you can see in data science, the applications are, which data science applications are basically in the finance, in the transport, healthcare. In the healthcare, you have the medical image analysis and drug delivery, bioinformatics, and virtual assistant. What is the medical? That is the image analysis. We have got the CT, X-ray, nowadays MRI. So images are there. The images have to be pre-processed. That is the filtering, are they enhancing, thresholding, are they done, those who are working. And then the feature is extracted, and then feature extracted, then used for the different categories or of disease or like that. Diagnosis there. That is simple way. And the other what is there, we are not going to discuss much more. So then what is this slide shows what is the requirement of the data science. There are 10 minimum essential requirements of data science is there. That is this data science minimum. One is that is this real world project skills, machine learning skill one should have. But what this slide shows, if you are going to work in the data science, so these are the expertise or these are the sub areas one should be aware of, or maybe they made aware of. That is the things is there, the slide. So data visualization is there, data wrangling and reprocessing, grading skills, Python R, that is coding is done by Python R mostly, but you can do MATLAB also, but preferably there. And then math and statistics is there. Statistical methods are required, particularly linear regression and all these there. And this adaptive, all the ethical skills of that is there. Team player skill means we have the group you can work or learning skill. So these are the concepts derived. So basically in data science, what you have to do, data representation and exploration, data representation and transformation, data deduction, data visualization and presentation, predictive analysis, machine learning. So machine learning methods are like your ANN, artificial neural nets, SVM, support vector machines, and these are they are required for the prediction of the diseases or maybe the healthcare in the sector. Data varying data is there. Data skill like data science will provide both the necessary background that you need to pursue advanced concepts such as deep learning, AI, and it means the basically what is called machine learning is the has sprung up from AI. It is a very now it is a branch of what is a core concept in machine learning. Learning is concept from cognitive psychology, and machine learning in that means learning methods like self-organizing, adaptation, and then yeah, they are deployed in the program and the algorithms. So that becomes the machine learning. So what next is that we have covered is the one just a last slide. I have prepared that. There is one more slide. Anyway, so yes, it is here. So what I have just here I have outlined why the AI and expert system is healthcare. Just outline. One part is information processing and transmission. That is very important aspects of the medical informatics, that is telemedicine. What it entails communication and computing and security of information. That is the one aspect, telemedicine. And second, modern aspects of the IoT based system. So whether you need a sensors, cloud computing, and security of the information. So what is the concern with the IoT security aspect is there. And sensors are there, but you have the low level, all the sensors, medically, maybe the signals are there or images are there. Then you through this send to the cloud, and therefrom you get the different resources to get the information. And then it goes to the computing system, and then it is dispersed to the different agencies which they call for. Then another is disease diagnosis. It is signal based, that is diagnosis. The ECG, electrocardiograph, electroencephalograph, brain, EMG, neuromuscular. Each corresponds to the cardiac disease. ECG, EEG corresponds to neurodegenerative disease, where Alzheimer disease, and this is your Parkinson disease, AD and PD. The very important nowadays research area in the application of medicine is AI medicine or something, machine learning, all these things. Another is neuromuscular disease correlated with the EMG. Then you have the images, X-ray, CT, MRI. So there tremendous work is there for the image processing of the biomedical computing. So these are the things we have done, and it is for the personal, that is myself have worked with. Presently I am working my student with language processing brain. Some of the students in NIT, and some of the students have completed in IIT BHU there. And that the work was basically long earlier that were done is on the episodic memory, that is bioinformatics, and also hidden Markov model. That's a very important work that was done by Babita Pandey. That is the most of the work of the neuromuscular diseases. So see, earlier they started with 89, 91. Work was there, published in Elsevier, two papers. These two papers, yeah, expert system in application, they are very important. Integrated intelligent model for the interpretation of EAG, muscular disease. And the another was a review paper in medicine. These are two very important papers. Other papers are there. Then another milestone work that we have done very long back with my students and myself, maybe published in 91 in Springer, that on EEG. EEG, so personally, we have some experience with my student working in EEG, based neural muscular diseases, and EMG, neural disease, and EMG, which are done for epileptic discharges. Anyway, so, and then EMG also, long back. So we have some experience in working in the area. So my suggestion, any one of the participants interested in working in the biomedical field, particularly in the medical diagnosis, what are the areas I have told, they may contact. So this is summarizing the thing that there is a interaction between the concepts and philosophy or principle in the AI with the machine learning and all these applications in the healthcare. So that's why it's my talk. So any queries from your side, you can go ahead. Hello.
Yes, sir.
Any queries from any of the participants, they can come forward. Otherwise,
Okay, sir. Thank you, sir, for accepting our invitation and giving your precious time. We are highly obliged to this. Once again, thank you, sir, for giving us a brief history and evaluation of AI and informing us about expert system and machine learning. You also made us aware of the skills we need to have to become a successful data scientist. You shared with us an overview about how AI combined with IoT can be used in medical informatics. Thank you, sir, for your respect talk.
thank you all for your kind attention. Thank you all. Okay, then we leave now, right? Okay, once again, thanks.
Now we are having next resource person, Dr. Dilip Sodia. Sir is online right now. Sir, am I audible? Sir,
Yes, Dr. Dilip,
yes, yes.
you're audible.
Yes, sir.
Good afternoon.
Thank you, sir. On behalf of our, I will continue. So,
Yes.
sir, yes, sir. On behalf of our institute, I cordially welcome to you, sir. So, right now, I will introduce about him in brief. Dr. Dilip Sisodia is working as head of the department at Computer Science and Engineering Department of NIT Raipur. He is working at NIT Raipur since August 2008. He also worked as a summer research fellow at Machine Intelligence Unit, Indian Statistical Institute, Kolkata, India in 2013, and adjunct faculty at DSPM, International Institute of Information Technology, near Raipur, India in 2018. He has over 18 years of academic and research experience in various engineering institutes. Dr. Dilip Sisodia contributed more than 100 referred articles, including 75 papers in Web of Science, Web of Scopus Index Journal, conference proceedings, and book chapters, published by international publishers. Dr. Sisodia successfully executed sponsored research and consultancy projects funded by C Coast and AICE Bangalore. He has supervised 4 PhD and 8 MTech theses. He is serving as an active reviewer for many reputed scientific journals such as IEEE Transaction on System Main and Cybernetics, IEEE Transaction on Cognitive and Development System, Expert System with Application, Knowledge-Based System, Information Fusion, Information Science sector. He has delivered more than 50 invited talks and lectures in conferences, workshops, short-term courses, and academic events organized by various institutes. He has organized many international and national conferences, FDP, STTP, workshop, etc. for engineering faculty and research scholar. Dr. Dilip Sisodia is a senior member of IEEE and ACM. Dr. Sisodia received a PhD degree in computer science and engineering from the National Institute of Technology, Raipur, India. He earned his Master Technology and Bachelor of Engineering degree, respectively, in Information Technology, with specialization in Artificial Intelligence and Computer Science and Engineering from Rajiv Gandhi Pratyogiki Vishwavidyalaya, Bhopal, India. His primary research are application of machine learning, soft computing, AI, biomedical signal image processing. Sir, it's an honorable moment for our institute to have your prestigious presence in today's event. We are truly inspired by your deeds. I hereby request you to for enlighten our minds with your talk. Expert talk.
Thank you, Dr. Dilip, for your generous introduction, and good afternoon, all the participants present over here. Now, I would like to share my slides. Actually, although I've been informed that I have allotted 15 minutes, so I'll try to conclude whatever I want to share within 15 minutes. And if time is over, please let me know without any hesitation. So first, yes, this screen you can see slide. Hello.
Yes,
Yes, sir,
sir.
we can see.
Okay, thank you. So the topic of this talk is decision tree based machine learning models and theory and its implementation. First, I would, this is the content of my presentation: importance of learning, traditional programming versus machine learning, classical definitions of machine learning, popular examples of machine learning applications, classification of machine learning models, decision tree algorithms, example of decision tree, and Python implementation of decision tree classifier. And if time will permit, then I may cover this evaluation measures for classification models. So first, I would like to start with this, what is the importance of learning? So learning is any process by which system improves performance from the experience. And how we learn? Actually, we learn from our past experiences. And in case of machine learning, this past experience is incorporated in form of data. So this learning can be used like where human expertise does not exist, or humans are unable to explain their expertise. If solutions are changed over the time, and solution needs to be adopted in particular context. So these are few instances where we can use this learning. Now the question is why this learning, or categorically this machine learning, is so important nowadays. Although this machine learning is a very old subject, and as you may be aware that this machine learning is a one part of artificial intelligence. You can say the first data science, and the one part of data science is, or we can say the artificial intelligence. In this one part, the learning field of artificial intelligence is taken care by the machine learning, and then further this special type of machine learning algorithms are known as deep learning. So this is, we can say, in this way, this is our DS, and this is our AI, and in this ML, and out of this ML, this is DL. So in this way, we can understand what is the correlation between data science. Data scientist, no doubt, is larger aspect. But now why machine learning or this deep learning is gaining popularity? Because machine learning first it was coined in 1956. But what is, as I am saying, that how we can aid, how we can learn? We can learn from the experience. And in machine learning, how we can incorporate the experience? By using the historical data or past data. So nowadays data is cheap and abundant, available in form of data warehouses, data mart, but knowledge is still expensive and scarce. Like we are generating, whatever we are discussing these topics, then we are generating data. We are using social media, WhatsApp, or we are visiting some malls. Everywhere we are directly or indirectly generating the data, and this data can be converted into use. This data can be further crunched and it can be generated values. So nowadays, just because of availability of data, now data capturing technologies are also improved. Different types of sensors are developed so we can capture any sort of data, and sophisticated algorithms are available, so easily without doing any coding we can process any amount of data. So nowadays this machine learning or deep learning or any sort of very advanced learning algorithms are easy to develop and demonstrate exhibited their capability. So basically, in our context, learning a general model from data of particular examples, and we build a model that is good and useful, the approximation of the data. So this is a brief about the learning. Now, what is the difference between traditional programming and machine learning? In traditional programming or in traditional systems, we provide the data and set of instructions, what we want to do. So exact set of instructions is supplied to the data, and what we'll get output. Contrary to this, in machine learning paradigm, what we'll do the data. Suppose we are providing the telecom customer data, and we are giving the output also. Output in the form like the list of customers or the number of customers who are going to leave this particular services of particular XY telecom company in next 2-3 months. So this is the output. So in machine learning, we are giving data and output, and we are expecting the rules, or we are expecting the program. So this is the fundamental difference between the machine learning and traditional programming framework. I just quickly, what is the difference between ML and traditional program? So different in form of inputs. Like in traditional program, input is limited to the use of letters, numbers, and symbols, and limited type of communication media such as keyboard, mouse, disk, etc. But in machine learning programs, inputs can be varied. It can be any perceived by our sensory organs, and it can be converted to digital input like sight, sound, touch, smell, taste. So anything can be converted into input. Different then the processing, difference in processing, way of processing the data. In traditional program, manipulate the stored symbols using the set of previously defined instructions or whatever program you write. But in this ML machine learning paradigm, these machine learning programs engage in pattern matching and problem solving, where information about the world presented to the ML program in digital format. So it can be used to solve the complex problem. What it means these ML programs not limited to only processing the information. They can also find the pattern under inherent pattern exists within the data, and to solve the problem, they can also, if program is capable, ML programs can be made capable to infer the inherent thing from exists within the data to solve the complex problems. These ML programs can self-learn, potentially including developing its own new algorithm to achieve an objective of which program was created. So it's not limited to this fixed set of instruction. It can expand with the help of these patterns. It can be increased to the it can enhance its capability and do. So similarly, in form of output, traditional programs limited to alphanumeric uh, uh, alphanumeric outputs communicated on computer screen, paper, or magnetic disk. But in machine learning, the output of traditional the output can be in form of synthesized speech, visual representation, manipulation of physical objects, and movement. Means the machine learning can do many more things as compared to the traditional programs. There are some classical definition of machine learning. So machine learning is considered a science of art of programming computers, so they can learn from the data. Machine learning is the field of study that gives computers the ability to learn without being explicitly programmed. The author Samuel first coined the term this machine learning in 1959. This machine learning is, you can say, the subset of large suite of AI, and that focuses on teaching computers how to learn without need to be programmed for a specific task. Author this Tom Michel also defined the machine learning in form of PT&E, where the computer program is said to be learned from the experience with respect to some particular task T and some performance measure P. If performance on T is measured by P improve with the experience E. So these are again not limited. These are some definition popularly used or mentioned in textbooks, or we can say these are some classical definitions of machine learning. These are some popular applications like spam filters. Every day we are using this application, like these email services, Gmail, and this Yahoo, and all these are using this spam filters, extensively using this just to segregate the incoming messages, whether these messages are spam or ham, or it should be delivered to the spam folder or our main inbox. The recommendations engines used by this Netflix, Amazon, and Spotify, and these services are using this recommendation engine. These are also examples how we can filter the content, how we can suggest the new content to the user, because like on Netflix online platform, the millions of movies are available, and it is very difficult for us to exhaustively search all the movies. So depending on our interest, this platform will automatically recommend some movies. So in this way, might be heard about this 1 million Netflix competition, how they given the challenge. So these are extensively used. The self-driving cars nowadays developed by the Tesla, Google, and many more companies. In some US cities, European cities, they have been deployed on the road also for as a test. And this facial recognition in photo services from Facebook, Google, this Google's Deep Point AlphaGo computer, which is successfully learned to master the game Go, personal assistant, Apple Siri, Google Assistant, Alexa, and there are many more these applications popularly we are using. So either way, not exactly the simple. There are different types of machine learning algorithm. It may be reinforcement algorithm. It may be deep learning, or there are different ways. So either way, they are using this broader means these are the applications of machine learning algorithms. So why we use this machine learning means problems for which existing solutions required a lot of hand tuning or long list of rules. The same task can be done by the ML algorithm, but using the simplified code and better performance. These complex problems for which there is no good solutions at all using the traditional approach, then the best ML techniques can find a solution. Or some fluctuating environments, it is very difficult to constrain. So in that case, we deploy these ML solutions without tiring or without compromising with the precision and accuracy. They can adopt the new adopt the changes in fluctuating environment. So these are some applications. I would like to skip this content because it may take some time. So this example is simply how we can design the simple spam filter. If manually we will design this spam filter, then we have to write rules like how to identify the spam emails. So obviously there are some keyword. Either it can be done through the subject line, or it can be done through the content of the email. So first we will identify the certain words like for you, acronyms, credit, fraud, lottery, free, or friendship, or such type of words which are generally used by the spammers, like your credit card is blocked, or such type of messages are frequently found in the spam emails. So we can identify. So for that we have to collect number of emails, like 100 emails, 1000 emails, or millions of emails, and find out such type of keyword, and exhaustively write the rules, set of rules, that if there is a some acronym is used like for you, or some fraud, credit card, lottery, free, or such type of words are there, then depending on the frequency of such word or appearance of such word, we will classify this email will be spam. So we can there are patterns available, and it is very we can say the time taking to write the exhaustive list of rules from the emails. And even if we write the set of rules, then the spammer may notice that my messages are classified to the spam just because of the presence of these words in my email. So he or she may cleverly change these words, and in that case again we have to write, like suppose spammer notice that all their emails containing for you are blocked, so they might start writing for you instead. So spam filter using the traditional rule based techniques would need to be updated to flag for you emails. And if spammer keeps working around your spam filter, you will need to keep writing new rules forever. In place of doing this tedious task, we can deploy the ML based solutions here. So what ML based solution, how this ML based solution will work? We can collect the thousands or millions of emails, some Enron email data set or some benchmark data set already available, and we can find out we can perform the NLP techniques, and find out such type of word and design a ML model. So this model will automatically, if there is a change, if a spammer will do some changes, then model will automatically detect the for such type of solutions, I have just given this simple example how we can deploy the ML solutions. So we can use this type. Now, why this ML machine learning based? So algorithm machine learning is growing. So machine learning is preferred approach to. One reason is its application, diverse application. Nowadays, these ML solutions are available in almost every field, like speech recognition, natural language processing, computer vision, medical outcome analysis, robotics, computational biology. These are the computationally, these are the very difficult tasks. Like speech recognition, very precise, because there is a narrow difference between the frequency of one to other person. Accurately mimicry is also possible, so accurately detecting is very challenging. Similarly, for so many thousands of languages are available, so parsing it very difficult. So the point is, first reason of growth behind the machine learning is availability of its application in all fields. Then second is, as we are saying, the data is work as a fuel to the ML algorithms. So this improved machine learning algorithms nowadays, every year, or even say every month, we are getting new advanced algorithms, improved data capture, networking, and faster computers. So earlier it was very difficult to get. Now every mobile is good quality of cameras, sensors are available, gravity sensor and different types of sensors are available in some smartphones. They can read your pulse, and all these sensors are available. So this data capturing technology is significantly improved, and the communication is fast, processing is fast. So this also accelerate the growth of machines. Software too complex to write by hand. So in machine learning, different types of open source packages are available. new sensors, input output device, and demand for self customization to user environment. So these are the reasons behind growth of machine learning. So we now quickly we come to the classification of machine learning, as this machine learning field is a, you can say, it's like a, it's not a subfield, it's now independent discipline like computer science engineering. Now many universities are offering the courses, BTech, FTech courses, and specialized courses in machine learning. So the classification, the different ways of classifying, it's a very large, it is very difficult to cover in one course or one lecture or one. So first we will, how broadly these machine learning models are classified. So depending on like what data is available. So on the availability of data, these machine learning models are classified, or machine learning algorithms are classified as supervised, unsupervised, reinforcement learning, semi-supervised, active learning, transfer learning, and etc. So, and how we are getting the data? First classification is based on the availability of the data, what type of data is available, how we are getting data, so whether online versus offline, or different types of model like probabilistic model, non-probabilistic model, generative model, discriminative model, parametric model, non-parametric model. So these criteria are still not exclusive. We can combine them in any way what we want, but these are the, we can say, the standard way of classification. So first we will discuss what is the different algorithms. So first, like supervised algorithm. In supervised algorithms, the input data as well as output labels are available. So if data is available as well as the labels are available, or we can say the target is available. Like for example, some images are provided to you, and patient images, X-ray images are provided to you, and these images are also labeled, whether this X-ray or this image is with particular disease, this image with not disease, this image with particular disease, this is not. So this is the labeling, means every image, whatever data is provided to you, like for example, email. So 100 emails are given, as well as their labels, their targets. This email is a spam, example of spam. This is the example of name or not spam. This is example of spam. This is example of spam. In this way, if label data is available, then we can say this such type of data we can use supervised learning model. This again, this supervised learning can be used for further divided for classification or prediction. Means if these labels are available in discrete, like whether the email is ham or spam. So there are two classes only. Particular email is spam or not spam. Then we can classify this. This problem is considered as a classification because labels are discrete label. Only two. Yes or no. It can be 3, it can be 4, it can be 5. Means problem can be of multi-class in nature. But still the labels are discrete. We can count, it can be 2, 3, 4, 5. If 2, then we'll say the binary. If more than 2, it's a multi-class problem. But in regression, the labels are available. Both regression is also supervised. Means here input data with output or target is required. But here the labels are the continuous value, like stock prediction. So stock prediction, stock value can be of anything. We cannot classify. Yes, the same problem can be converted to classification, whether this stock will be grow or not. This is the classification, but exact prediction of its value is a regression because all labels are discrete. So this is the how supervised algorithms will work. So I will give a simple example. Here the training takes this training data. It can be of documents, images, sound, or anything. So first we have to convert this training data into this, whatever training data we are using. It will depend again domain, what domain we are using. If we are using email, then we can collect the email documents. If we want to count, so first we have to collect the raw data, and this data will be converted into feature vector. Feature vector means everything. This is, suppose we are taking the email 1, email 2, email 3, and so on, email n. So we have to extract like word 1, word 2, word 3, and n number of words. Like for acronym, and this word 2 is not present. In this way, we'll extract certain attributes from the data. If suppose in case of email we are using images, then image 1, image 2. In this way, this image 1, image 2, then we have to extract the features, or we have to define these images on the basis of certain attributes. So there is a little difference between attribute and feature. One attribute may lead to multiple features like F1, F2, F3. So these are the features, and this is the attribute. Like suppose salary is your attribute. Salary is an attribute, and multiple features can be derived from this salary. What are the possible multiple set? Like what will be the mean salary? What will be the medium salary? What will be the maximum salary? So like these mean, medium, maximum, these are the features derived from these attributes. So in machine learning, generally these terms are interchangeably used, attribute, and one attribute will lead to one feature, but one attribute will lead to the multiple features. So features are basically the exact numerical value, and we have to extract the feature from this text, whatever document we are using, whether this is the image, sound. So if we'll consider the sound file, then their pitch, frequency, and different sound parameters we can extract, and we will prepare the feature vector. Feature vector is nothing but when particular like email, this email will be represented by certain 0.1 certain values, then this component is known as vector. Okay, so this vector and matrix, generally mathematically we use these two terms. So we have to extract the feature vector, and now this feature vector will be hello.
Yes,
Yes,
sir.
sir.
Audible, sir. Audible.
Okay, thank you.
Audible, sir.
Yes. So this feature vector, now this feature vector is passed to the ML algorithm. Okay, so this first we have to extract these numerical values. First we have to identify the attribute. Suppose you want to design a program for prediction of whether this students have taken admission into your institute, and you want to predict whether this student will get job or not. Okay, so first of all, the student should be attributed. Means every student we have to find out the attribute. Okay, now attribute can be anything. Like you want to predict whether this student will get place after 4 years or not, and for that you have to identify the feature or attributes. Okay, and this attribute may be anything like what is the height of a student, what is the weight of a student, what is the blood group of a student, or what is the so this height, weight, blood group, or father's name, these may be the attribute, but these attributes are not relevant for in this particular context. Okay, you can collect the 100 attributes, but all of these 100 attributes, single attribute will not contribute to your problem, because your objective is to predict whether this student will be placed or will success in its academic endeavor or will not. So for that we have to identify the most relevant features. And this whole process is known as feature engineering. We have to identify the relevant features. What can be the relevant feature for this particular task? Yes, because height, weight, color, they will not contribute in your if suppose you are, it can be if you are the same thing is predicting for sports or particular sports where height may be contribute, then it may be relevant. But for academics, they don't play any role. Okay, and then we have to find out the relevant features like what was the score, high school score, higher secondary score, competitive exam score, or in suppose family background. So father's job can be useful because it may be some awareness level, schooling, and like this. So in this way, we have to identify the relevant feature and extract their feature values. And now this feature vector will be passed to this machine learning algorithm. And this algorithm will train. Simultaneously, we also, because whatever we are doing is from historical data. And already we have 4-5 years past student data on the same features. And this label will also provided. So input will be the feature vector as well as the labels for this machine learning algorithm. And now what is the difference between algorithm and now this algorithm, trained algorithm is known as model. So now this algorithm will be trained when feature vector, input feature vector and label is passed. And now this algorithm will be converted into model, or we can say the predictive model. And now we'll present the unknowns. For example, the next batch students. So we will provided the test data, or we can say the unknown samples, and the same process we have to extract the feature values, and this trained model, now algorithm will be trained and then algorithm is converted into model, and then it will give the output whether the student will be placed or not placed. So in this way supervised algorithms will work. This you can see that this example is some labels like this mail is a not spam, this is not spam, this is spam, this is spam. So on the basis of this training we will predict the new instance. So this is the way how supervised algorithm will work, again depending on whether our labels are discrete or continuous, like stock prediction, house price prediction. These are the examples of regression problems, because here labels are continuous, and the other these are the classification problems. Similarly, if labels are not available, because the cost of labeling is very high, it is suppose you want to, means this labeling is done by the expert, domain expert. Suppose we are considering the medical images, then who will decide whether this X-ray or this MRI will suffer from this disease or not? Obviously, expert, doctors, and the cost of labeling is very high. So it is not necessary for prototype problem or well-known problem we can get the labeled images. So the cost of labeling, as well as there is the issue of accuracy. So sometimes we have to go without labeled data, and for that this unsupervised learning will play the role, like these clustering algorithms, dimension reduction, or the association rule mining. And for this these are known as the unsupervised learning algorithm. Whether the same thing, we have to decide the raw input data, then extract the feature. But here labels are not provided to the machine learning model. Now models will be different, like this K-mean, K-metroid, hierarchical clustering, PCA. There are so many algorithms. So again, how it will do? So definitely there is no miracle. There will be a set of mathematical technique, like we will measure the distance, their similarity, and on the basis of this distance measure or similarity measure, it will group just like this. This is our training data. So on the basis of how these two persons will be close, similarity, how we can find the similarity. So obvious, we'll form their group, like if all students are, if they are the same branch, same hostel, or same belongs to same district. So these can be of anything. So on the basis of their similarity or dissimilarity or distance, we can group this information, and in this form this unsupervised algorithm will work. Examples of unsupervised algorithm. Then nowadays this supervised and unsupervised algorithm, these are the saturated, and so new area like semi-supervised. So this semi-supervised is nothing but the combination of supervised and unsupervised. What combination means? The partially labeled data is available. Just suppose out of 100 instances, we have only labeled for 10 instances, and with the help of these 10 instances, we can label the rest of the data with certain percentage of accuracy. So we can move with this semi-supervised algorithm. So nowadays this semi-supervised means a lot of work is going on in semi-supervised learning algorithms. We can say we can take some partially labeled data. Just suppose you went to the doctor with 10,000 images. We want to do the experiment with this. So doctor can label 100 images at most, and then with the help of this 100 image, the remaining can. Next, another popularly growing area of machine learning is the reinforcement learning. And nowadays, like these driverless car and this game playing, robotics, So these are the popular applications. So what is the way of working of this reinforcement learning? So in reinforcement learning system or this reinforcement learning system, we use a term agent, and this agent can observe the environment and select and perform actions, and on the basis of the rewards or penalty, it will decide the next action. Means if your action is in positive direction, if agent will take some action, and if action is positive, like agent is now you are driving driverless car or robot. Okay, so if your robot will observe there is a fire. Okay, if it observe the environment, there is a how it will observe on the basis of the temperature. If there is a sensor, sensors are embedded in your this agent, so on the basis it will take the temperature, and means fire can be of any type fire, so it will take action. Whether this action is appropriate or not appropriate, it will give reward or penalty. In this way, this your agent will learn. So automatically these robots, before this Boston, you maybe heard about this Boston Dynamics, they have developed the robot, and their years, 2-year, 3-year training is there, and over the period of time they will learn, and when they will learn, like what type of obstacle, what action it should take, and in this way this reinforcement learning algorithm. So this deep minds AlphaGo, I think this is the multiple times he defeated the world champion. So then one more way is transfer learning. Hello.
Yes, sir. Audible, sir.
No, I'm audible, but I think I'm not taking much time. Or
Yes, sir.
fast. How much time is available?
Sir, 10 minutes.
Only 10 minutes.
Yes, sir. 10, 12, 25, 325.
Okay. So the next is the transfer learning. So nowadays this is also another emerging area. What is this transfer learning? Concept of this transfer learning means you can transfer the knowledge of one domain in learning of other domain. Suppose if you want to learn something, like you want to learn the driving the car, and if you have your past experience of driving the tractor, then comparatively it will be easy to learn the drive, because many learning knowledge can be transferred to this. So in some domain, the label data are in short, as we have said, that there is a scarcity of label data, as well as the cost of label data is very high and expertise is required. So label data are in short supply. The calibration effort is very expensive. Calibration effort means whether this is correct or not correct. The learning process is time consuming. So what we are doing, we are searching the other alternative. If everything is given, input is given, label data is given, then easily we can apply the supervised learning algorithm. But if all these things are not, then how we can learn? So we can reuse the model that was trained while solving one problem, applying to the different but related problems. Like in this during this COVID pandemic. So initially there was no cases, some data sets are there, so we have to start. So in that case, we can related SARS viruses are there, their images, and we can infer. So this transfer learning can be done in different way, like this homogeneous transfer learning and heterogeneous transfer learning. Homogeneous, if the input feature space between the source and target both are same, then we can use the homogeneous transfer learning. If input feature space and the target feature space, source and target feature space between the source and target is different, then we have to perform the heterogeneous, then we have to compute the data distribution between the source and target. And so nowadays you can find the pre-trained models already, these ImageNet and many more such examples are there, and these pre-trained models are used to solving the many problems. Their results are very good. And similarly, this one more is active learning, where in this active learning can choose its own training example or ask teacher for an answer on selected inputs. This in active learning, what we'll do, it can select normally we have to provide the training instances where in this active learning, this learning algorithm will out of the multiple options, it can select the most appropriate training example. Now you can see this is the landscape of machine learning algorithms, and you this classical learning can be like machine learning in classification, neural network, and this classification can be supervised. This classical learning can be supervised, unsupervised, supervised further classification, regression. Different models are there. So this picture is nothing but only to show the landscape of machine learning, how much things are involved in machine learning. Like only for dimension reduction techniques, we may be aware about this only PCA, but this SVD, PCA, LDA, LS, TSNE. So all these are only for dimension reductions. For reinforcement learning, multiple options are available for ensemble. So this is, but good thing is that we don't require to implement all these algorithms. This is the snapshot. Many more algorithms are there. So similarly, many tools are also available, and most of these tools are free. Means most of the algorithms are already implemented. Like popularly, we are using the scikit-learn Python library. So most of these algorithms, whatever given is, are already implemented. And one more popular this suppose you do not want to run the library also, then some graphical tools are available. GUI based tools are available, like this Weka Rapid Miner. Here you have to use drag and drop or icon, and you can do your work. This MATLAB, and or we can say the MATLAB is a proprietary, so it's a open source Octave where most of the algorithms are available. For deep learning, the different this TensorFlow, CNTK, Cafe, PyTorch, different. Some are provided from Facebook, some are from Google. So these libraries are available. So this is all about brief about what is machine learning. Now we'll come to the out of this machine learning, because it is very difficult to cover. So here we will try to learn one or two algorithm. Dr. Dilip. Hello. Hello.
Yes, sir. Audible, sir.
Yes. When your time is over, you just stop me, okay?
Yes, sir. Yes, sir. Right now, yes, sir.
No. Don't hesitate to ask me, because I've already told you that the content is much more, and although I am doing it fast at my level, but yeah. So you can ask me if your next speaker will join. You ask me, okay?
Yes.
So, what is this supervised learning? Because in supervised learning, our object is this mathematically we can define it y equal to fx. Y is our output, x is our input feature vector, and f is a function. Learning means we are learning this mathematical function. This function can be of anything, and this x is our input. So, give a training set labeled example like x1, x2, x1, y1. X2, Y2. So here X1, X2, Xn, these are the input, Y1, Y2, Yn, these are the output. And our objective is to learn F. And when this F is some mathematical function, when this function will be trained, this function will be learned, then we can provide some unknown sample or test sample X, and it will give some output. Here, this picture itself is a. So first we take the historical data, extract the features, labels, provide the labels, algorithm. This algorithm will be converted into model, and for new data we have to extract the feature and provide this model, and will predict the result. So now there are different algorithms. Out of this algorithm, one important family is the decision tree algorithms. So decision tree is not a single algorithm. This decision tree family consists of many algorithms. These decision tree algorithms still keep their popularity nowadays in data science, machine learning, because they can produce the transparent decision. Although there are superior algorithms are available, even in fact, the deep learning is superstar of ML nowadays, but it is opaque algorithm. Means they will give you the best result, but you will not be able to dig the reason why we are getting this. So we can say these algorithms are not sorry. Okay, so these algorithms are still popular, means lot of business values are still generated by these decision tree algorithms. And so in this decision tree family algorithms, there are many decision tree algorithms. Out of these decision tree algorithms, 2-3 algorithms are very popular, like ID3. Although ID3 is not used nowadays, ID3 is iterative dichotomizer, and this ID3 itself is a successor of D3. So because ID3 itself is not in use, so we'll not discuss the past beyond that. So this ID3, and there was some problem with this ID3, means there was some bottleneck with the ID3. So some improvement. This ID3 was developed by this Rose Quinlan, and due to this bottleneck, they have developed or modified this ID3, and the next higher version, or we can say superior version of ID3 is C4.5. And in Beka we use J48 algorithm. This J48 is nothing but, because this ID3, this C4.5 is a copyrighted some code issue. So rather than including C4.5 as it is, they have included Java implementation. This is known as J48. So J48 is nothing but the Java implementation of ID3. So ID3 and one more decision tree algorithm, which is known as CART, classification regression tree algorithm. In scikit-learn, by default we are using classification and we are not choosing any parameter, then we are using a CART algorithm. And what is the difference between this CART, ID3 and C4.5? We'll just see. And this J chi-square automatic interaction detection platform, multi-level, this Mars. So in this way, means tens of decision tree algorithms are available from this decision tree family. Okay, so this decision tree is basically a greedy based algorithm. Tree is constructed in top-down, recursive and concur manner, and stating all training examples at the root will be considered, and we will select a particular route. How we'll select a particular route, why we select a particular route, we'll see. And in this way we will start first out of the whole data set, we'll select particular attribute, then it will be converted to tree like structure, then again we will evaluate the attribute, and recursively we will do the same process. And after some time we'll stop, we'll define the stopping condition, like all samples of the given node belongs to the same class. When there is no possibility of further splitting, then we will stop, or there are no remaining attributes for further partitioning, then we will stop, or though there are no samples are left, then we will start stop. So in this way, which first there will be a root node, we will perform the split. So this is either it will be a decision node or it will be a leaf node or terminal node. Terminal node means if all attributes are homogeneous, means they belong to the same class, then we will stop. So the read node splitting means process split node is represent the entire population, where we will perform the first splitting. And then this splitting means process of dividing the node into two or more subnodes. Then there will be either decision node, when there is a possibility of further split. Leaf node means leaf node do not split, and it is called terminal node also. Pruning is just a reverse of the splitting, where we will in splitting we will divide root node into, here we will remove the some part of the tree. So in this way this decision tree will be. So decision tree can be used for classification, categorical variable decision tree algorithm, or continuous variable decision tree algorithm. Now here you can see, suppose a small data set is given, like this by computer data set is given, where we are considering the 4 attributes: age, income, student, credit rating. So these 4 are attributes, while this 5th is a class and first is a we can say the serial number or ID. So these 4 attributes, what is our objective? When we will apply a decision tree algorithm, then such type of decision tree will be generated. Such type of decision tree will be generated. Now there will be, hello?
Yes, sir, audible. Sir, time is over, sir.
So I will take only, you just give me 5 minutes. Okay?
Yes, sir. Thank you.
So I will conclude it. So our objective is to, when we will apply a decision tree algorithm, such type of structure will be created. Because this is the hierarchical structure, so it will not possible computer, but this structure is showing the set of rules. Different set of rules can be, you can say like a student is no, income is high, age is less than 30, then by computer decision will be no. So number of rules will be generated. So this rule will be stored. and on the basis of these rules, this decision tree, if new instance will be presented, then it will classify whether your by computer decision will be yes or no. So now the bigger question is why we choose this student as a root node. Why we choose this student as a root node out of this? Why we not choose the age, income, or credit rating? So for that we use the concept of entropy. Entropy is the measure of uncertainty. And how to measure the of uncertainty? If suppose all instances of this are same, then there is no entropy or there is no uncertainty. But if there is a different, like some are youth, some are middle, some are senior, then order of uncertainty or some amount of uncertainty is there, and we will measure this uncertainty with the help of this measure entropy. Entropy means we are talking about the Shannon entropy only. There are different measures, different entropies are there. Out of these different entropies, we are considering only this Shannon entropy. What is this Shannon entropy? This Shannon entropy where Pi is the probability and we are taking the logarithmic of this Pi. Why we are considering this mathematical construct or this Shannon entropy only out of this? Because there are some properties which are necessary. On all these necessary properties are satisfied this Shannon entropy or not? Yes, all these. Is there any other measure who satisfied these necessary properties? No. So that's why we consider this Shannon entropy measure. And what are the basic properties? Like uniform distributions have maximum uncertainty, because just because of we can say the shortage of time, you just you can say the reading these properties without this uncertainty is additive for independent events, and adding an outcome with zero probability has no effect, and the measure of uncertainty is continuous all in absolute. Just because of these essential properties, we have considered this. I have given this link where you can find the many types of entropies are there. So we use this Shannon entropy, and there are the other properties, essentially uniform distribution with more outcomes have more uncertainty, events have non-negative uncertainty, events with certain outcome have zero uncertainty, and flipping the arguments has no effect. So on the basis of this entropy, we will use measures like for ID3 algorithm. For ID3 algorithm, we will use the entropy. Entropy is basic, and this entropy will lead to the gain or information gain. But this information gain is biased to the multi-valued attributes. Means those attributes where number of different attributes are more, then this information gain will favor this. So the next measure will be used by the gain ratio. So this information gain is used in ID3. This gain ratio is used in this gain ratio is used in C4.5, and in CART algorithm we use Gini index. So these are the means if we are using information gain, means we are using ID3 algorithm. If we are using gain ratio, we are using C4.5. If we are using this CART algorithm, means we are applying this Gini index. And what is this? These measures are basically for every attribute. Like here, for every attribute, for age we will calculate the information gain. For income we will calculate the information gain. For student we will calculate the information gain, and for credit rating we will calculate the information gain. And on the basis of this value, maximum information gain attribute will be selected. So in this way, we will select this attribute. And similarly, for if we are using C4.5, then we will use in place of information gain, we will use the gain ratio, and maximum value of gain ratio will select a particular attribute. And for CART algorithm, we will use the Gini index. So in this way, these are the formula for this example, but just to honor the your time deadline. Hello. So in this way, means the conclusion is, for decision tree family, you must aware what measure of uncertainty we are using, whether we are using information gain or gain ratio or Gini index, it will decide which decision tree algorithm will be. It's a simple how to apply, we can see it, but it requires 10 to 15 minutes more. Yes, Dr. Dilip. Hello.
Thank you, sir. Thank you. Participants, if you are having any kind of query related to this, you may ask. Yeah.
Sir,
Yes, please.
sir, where in healthcare application can this algorithm be used?
Everywhere you can use this decision tree. As I have said earlier, that decision tree algorithm, these decision tree family algorithms are still very popular. There is a random forest algorithm, which is a some advanced form, because the decision tree for very large data, this decision tree may not work. So in that case, one ensemble of this decision tree, which is known as random forest. So you can use this random forest for any complex problem to address any, whether it is in healthcare or anywhere.
Is there anyone want to ask?
So can we say that a supervised learning model is most efficient of all the models?
No. We can't say like this, because universally there is a no rule that such type of algorithm. It will depend on the problem. With supervised algorithms are convenient for from understanding point of view, for application point of view, but their requirement is the labeled data should be available. So there is no means anyhow we can't say that related to efficiency that more supervised, because other supervised deep learning algorithms or reinforcement learning algorithm, these algorithms are far superior than these algorithms.
Okay.
Oh, yeah. Is there anyone? Or we should? Okay, sir. So thank you so much, Dr. Dilip Sisodia, sir, for your valuable time. Your informative talk has provided us with invaluable insight about how traditional programming, decision tree, and machine learning works, and about designing of ML-based spam filter. You also made us familiar with different ML models like supervised and unsupervised, and also about reinforcement learning and its implementation in Python. I am sure our participants have attained a better understanding about all these topics. Thank you again, sir, for taking out your valuable time to impart us with your knowledge. Thank you, Sheikh, for giving
Thank
us.
you very much for giving me opportunity to share whatever I learned with the participants. Although just because of this time restriction, I was not able to complete the way in which I want. But still, I hope a little bit information may
Yes,
be
sir.
provided to the participants. Okay. Thank you. Thank you,
Thank you,
everybody.
sir. Looking
for
forward
listening.
to see you
Yes, yes.
once soon, sir, in our campus when college is going to be open.
Okay.
Yeah, of course.
Most
Thank you.
welcome. You're always welcome. Thank you. Thank you, everybody.
Thank you so
Thank you, sir. We are having next resource person, Dr. Prabhat Kumar. So thank you, sir, for accepting our invitation. On behalf of our institute, I cordially welcome you, sir. We are honored to have you with us. So right now, I'll introduce about him. Dr. Prabhat Kumar has completed his BA in Computer Technology in 1999, MTech in Information Technology in 2005, and PhD in the areas of wireless sensor network in 2014. He has a vast experience of more than 20 years in the field of teaching. He served as a lecturer in R.P. Sharma Institute of Technology, Patna from 16 November 1919 to 10 December 2005. Then he worked as an assistant professor, CSE department in NIT Patna from 12 December 2005 to 22 July 2018. And from 23rd July 2018, he is working as an associate professor in NIT Patna. He is currently holding various administrative responsibilities, among being chairman, computer and IT purchase committee, professor in charge IT services, PhD coordinator, and many more. His past administrative responsibilities include HOD CSE in IT Patna during 2016 to 2019, chairman Department Purchase Research Committee, state student coordinator, Computer Society of State Bihar under region Computer Society of India, and many other things he has holded. He has published, he has authored more than 100 publications, which include 51 international journals, 60 international conferences, and 2 books. He has also delivered 20 plus expert lectures in various prestigious institutions and organizations, and has been session chair in various international conferences. He is also member of various prestigious organizations and societies like senior member IEEE, ACM, CSI, IST, International Association of Engineers, Internet Society, IFIP Working Group, etc. His research areas include wireless sensor networks, IoT, cybersecurity, data science, and data analytics. He has supervised 10 PhD students and 25 MTech students. Sir, it's an honorable moment for our institute to have your prestigious presence in the institute, to have your in today's event. We are truly inspired by your deeds. I hereby request you to enlighten your mind, to enlighten our minds with your expert talk. Thank you, sir. Please.
Thank you, Dr. Dilip. Thanks for inviting me. And first of all, I want to congratulate you on selecting such a nice topic. Healthcare has a lot of potential to improve, especially with the inclusion of artificial intelligence and data analytics. So today, I want to welcome all the participants, and straightway, I'm sharing my slides. स्क्रीन शेयर करेंगे जरा, your entire screen करें. So today, my topic will be Internet of Things in Healthcare. I hope I'm audible.
Yes, sir.
Audible, sir.
Yes, sir.
Thanks.
Yes, sir.
So, So the agenda will be starting with IoT introduction, then the architecture and applications, and we will move to the healthcare sector. And the focus will be how IoT is impacting the healthcare sector as a whole. And then we will conclude by discussing some of the research issues and the challenges we are facing today. So IoT, Kevin Ashton in 1998 gave a very big statement that it had the potential to change the world, just as the internet did, maybe even more so. So at that time, people did not believe him. But today we can say that he was right in this prediction. It was formally introduced by International Telecommunication Union in its ITU Internet Report in 2005, the body which forms standards for these kind of things. Semantically, it means a worldwide network of interconnected objects, uniquely addressable based on standard communication protocol. But we need to take care that IoT is not only about communication. It involves much broader aspect. And with time, these aspects are increasing. So we are talking here about intelligence using data analytics, machine learning, AI, etc. So IoT is not only the connectivity things. IoT is, we are getting some services involving automated sensors, some sort of analytics, making the machines learn and getting the services. So IoT is a broad term as of now. So what we expect from these kind of devices, we require anytime connection, any place connection, anything connection. So if you see, anytime means even if we are moving outdoor, indoor, day, night, we want services to follow us. We should get the services at our convenience, at our location, at our time. Let's say you ask for a service in room 1 of your house, and if you walk down to the room 2, the services should follow you. That is that any place connection. You should get the, like when you are talking on your mobile phone and you are riding a bike or you are traveling on a car, you are not bothered which tower the mobile is connected to. It's automatically handshaking and going to the another tower. The user is getting seamless experience. That's what happened in the Wi-Fi connectivity at NIT Patna or in other institutes. The user is not bothered. So we want anytime connection, any place connection. And the third thing, which is where IoT has brought the revolution, you can say, is anything connection. It's not only mobiles. It's not only computer and laptops. It is human to human, between PCs, human to things, things to thing. We want our fridge to talk to our mobile phone. So it's not here limitation of which only smart devices will connect. So we need connections between all the tiny devices to the larger machines. So this connectivity should serve us as per our time and our place, as per our requirement. So this is the bigger picture of IoT, and a lot of things are changing around us, and it's going to change. So how it actually works? So the IoT architecture has 3 C's. So that is the collect, communicate, and control. And you can say that we people, the computer people, we have in a way stolen this from what God has already created. You know, that's why this figure you can see one side a human body is there. So how our human body works? We have our sense organs. We collect data, and then whether our hand or feet or anything, those data goes to our brain. So there is a communication network, and then the control signals is released by our brain. So we are trying to do the same thing in the IoT network. So these 3 C are very important: collect, communicate, and control. So for collecting, we in IoT environment, we use sensor nodes. These are tiny, low power, limited memory, short range communication devices. The objective of these sensors are to monitor activities, gather and fuse information, communicate with global data processing units. So here is a simple sensor diagram of a sensor node. So as you can see, there are 4 components. The power unit gives power to the other 3, that is the radio component, the microcontroller, and the sensors and actuators. So the radio is that part which is responsible for giving you communication and connectivity. So you can see this is the sensing unit. Those are the sensors responsible for collecting data from the environment. And data collected from the environment may be physical, chemical, biological. That depends on the type of sensors you deploy. Then the microcontroller, which gives the objects their intelligent, makes the object smart. Here, definitely you need some sort of a processing unit. So that is a microprocessor. These are small processors. But today, many of you are using Raspberry Pi and all those kind of things. So the processing capability is increasing at even controller level. The RAM size, the more nano comes into the development, you will have better controller, better sensors. So there is one sensing unit for collecting of data. There is a microcontroller for control the unit. Then we need communication devices so that whatever processing or data collection you do at the end, at the sensor level, it has to be communicated to a place where it can be analyzed, where certain decisions can be taken. And that's why you need a transceiver for sending and receiving signals. Regarding power source, a lot of changes has happened in recent times. And today we are also having that passive power sources. Active was always there, like battery power. Now, even in active, there are the concepts of RF inductance. So you can supply power through your nearby RF reader. So that is there. But the passive is changing the whole powering technologies. So you can have solar-based power. You can have vibration-based power. Even today, there are concept of Google interactive sensors. Even you can power by the push. So power sources, newer methods are coming up, which is again changing the way sensors work. If you see the types of sensor in this slide, you can see it's basically the engineering sensors we use. I've not included the health sensors here. It's there in another slide. But you can see, right, the range of sensors available. It's not only temperature and humidity now. We have reached to acoustic, vision, sound, vibration, leaks, magnetic sensors. So your mobile has many of the sensors and you use it for your playing and all. So now these sensors, the development has reached to us. Many more is going to come. So these slides tell you about the protocols we are using to connect all these IoT environment. And on the left side, you have the protocols ranging from power line, Ethernet, printed to RFID, Bluetooth. So, and on the right side, you can see the type of network. There's a PAN, LAN, MAN, and WAN. So from bottom to top, the size of the network increases. So on the left side, you can see the protocols has been arranged accordingly. So when you talk about a WAN, we are using LTE today and 5G, and also these are the protocols. So not talking much about the protocols. Let us see the services. So I'm trying to show you a visual. Please tell me if you are not receiving the sound. So the last slide show you how the controlling can be done. So it was a Intel's view of the future, and many of these things are happening. How sensors are going to impact our life, and how we are going to see the automation in the control and the delivery of services. And that's where different type of architectures and different types of requirement of sensors. And today's the theme is applicable. Like you need machine learning, you need artificial intelligence, you need data analytics. So it's not only collection of the data, it's a lot more. You have to analyze those data and then provide services to the humans as per their requirement. So Intel has his vision. Now, if you can see some of the application you have already seen, but smart homes is one area which we are already getting the benefits. Like you have the smart lighting systems now. You can control your home using your mobile. But this will eventually lead to smarter cities, as you seen in the video. And then agriculture is one huge area which is being impacted, and even Government of India. We are a little slow in the IoT in agriculture as compared to some of the developed countries. But recently there is a huge push by the Government of India on the IoT in agriculture. Healthcare, we are definitely coming to that. And then disaster management, smarter grids, logistic and transportation. So the application area is huge. Here is one diagram of intelligent home, which we normally teach in the MTech level at NIT. So these types of things are already possible. Then this is an area today, if you can see, even if nobody needs to stop at some railway station or some bus stop, the train or the bus will stop at the designated time, even though there is no ticket, from that station or to that station. Tomorrow we can integrate these things, do as per requirement. So we need smart transportation. Google Maps are giving you some sort of information, but that is also a little bit behind the time. So a lot of things are being done. They are also using analytics, and you are getting the estimated time based on the previous as well as the present trend. But a lot more is required. Now going straight to the topic of today's, the healthcare sector, and how IoT is going to impact the healthcare sector in a big way, how we are the future. So let's see, the healthcare landscape is changing, and it is changing with the the income level. The Indian income level is rising. The younger population are of next level, next generation. They are more educated, more healthy, better equipped to handle devices. But at the same time, certain prosperity has its own drawback. So the biggest of them is obesity is growing. That's poor diet. Though we are eating, but the quality of food, is not that good now. So the use of junk food more. Large number of old population. That's also one area which India is not facing right now, but many of the developed countries is facing now. But India will be the next one. If today you have the largest population of young people in the world, tomorrow that will translate into the largest number of old population. So we need to take care of those things. So it's the right time to start focusing on the healthcare sector, and that's what people are doing. And we, the computer science, are doing our bit on making this healthcare smart as possible. So 75% to 80% of the healthcare spending is on chronic disease management in India. But there is a huge market for new systems capable of improving productivity, minimizing cost, shift healthcare from hospital to home, because a major expense is on when you get hospitalized at a hospital. When you stay there, if you can transfer people out of the hospital to their home, not only the price point is beneficial, the atmosphere changes, and there is a better chances of recovery in the home environment. So, but if we shift to the home, then we cannot ask doctors to come and visit all 3 times in our home. So what is the solution? That's where IoT can fill the gap. We can make the doctors sit wherever they are. We can get the readings from the patient using this IoT devices, wearable devices. and do what can be done in the hospital itself. Definitely not for the ICU people, but for other cases. If you see the right-hand side slide, the government expenditure on healthcare in India, and see the growth, and it's going to grow even further. So if we divide the healthcare sector in various segments, because it's the same deployment or the same sensors or the same topology architecture is not going to work everywhere. So we have the research community has divided the healthcare sector in the various segments, keeping in view the IoT, and then one is pharmaceuticals, that the company that do the research development, the manufacturing of generic medicine, biosimilars, biologic active pharmaceutical ingredients, formulations. The second is the diagnostic. We have so many labs doing the tests, but then today what happens? Either you go to the lab or they come to you, and then so can we do something that the reports today they are sending on your email, so you're not going to the centers to collect those reports. Now then still you need to go to the doctor with that report, the printout of that report. Why can't the doctor also comes on the same platform, and a copy goes to him, and you do not need to run to the doctor? After all, once you show the report, let's say only 10% need to be analyzed again. Otherwise, it's the report and the medicine. So a lot of things can be automated there. Similarly, the medical equipment and tools, if you can have cameras, the sensors, so whatever goes inside can show you the exact situation inside the body. And hospitals, right from entry to exit to your everything, it takes too much time. Even I have my personal experience. I took my father to Medanta, Delhi, one of the best in India. It took 3 hours of the paperwork, then only he could get a room. So just imagine if those things can be automated now. So it's a huge potential. Why healthcare requires more investment? Let's see. This is the Indian Economic Survey of 2021 and 22. Please see these two figures. The pink one, that's due to non-utilization of healthcare services. And the red one, that's due to poor quality of care. See where we stand. India. The amount of people died due to these number of deaths, you can see more than 2 lakhs. So these are, even 1% saving is worth saving. Now we are talking about 2 lakhs, above 2 lakhs people who could have been saved or who could be saved. And this is not the first pandemic which has affected. In future, we must be ready to handle those kind of things. And what kind of issues come in. You cannot touch. Humans are transmitting itself. So you need better equipments, better sensors. Just imagine if we have sensors tomorrow which can detect the COVID virus. Life will be much easier, Everybody wearing masks. Rather, it should be that we should look at the virus itself, not the entire population. So things need to change, and technology is the only way to help these kind of issues. So the ecosystem, if you can see, definitely the patient is there. The first, the healthcare ecosystem, the major, the important part, the patient. Then the doctors, and you can consider hospitals included there. So there is a patient, and there is a doctor. There is a third component which is equally important: the service providers, the insurance companies, the health insurance. So you need all those 3 things. At times, you have a serious patient, you run up to a hospital. The doctors will say, okay, you need 10 lakhs of money. And now you start running up with the insurance company, whether I will be paid, whether I will not be paid. First, it will be paid, and lots of processing, which kills very important time at a very, very critical stage. So why can't these things be automated? And that's where IoT can be a big help. And certain extra services can also be provided, which is not there today. We can see there. So how IoT can benefit healthcare? So device gather and share information directly between devices and cloud. Data streams are collected, recorded, and analyzed faster and accurately, which results in minimizing patient-provider gap, improved patient engagement, identifying patient needs and provide personalized services, improved decision making, which ultimately will lead to the reduction in healthcare cost. The hospital's costing will decrease, so will our bills. So this is quite possible. If you can see diagrammatically, we can put in wearable devices on the patients, which will help in sending accurate and real-time data to the doctors wherever they are. So the same doctor can handle more number of patients. Okay, and the patient data, the doctors can control through wearable devices the delivery of medicine and also. So it's a both-way combination. Similarly, those data can be sent to through the fitness app to the you can say the insurance providers. So it is not only when you are ill. Let us say there are two different people, two friends. One is keeping track of his health, eating good food, doing the required jogging and exercise and all, and another doing nothing. Today, both are required to pay equal premium. But what should happen? People should be encouraged. People should be encouraged that you keep yourself fit, and if you keep yourself fit, you will pay less. So it's not only the amount which is being saved, it's also the encouragement part. So this IoT can help creating an atmosphere, creating an environment where a fit India can be produced. People can be made aware, people can be encouraged, people can be given incentives in different forms. And that is what is happening in many of the developed countries now. They're trying to incentive. Even, in future, it is possible in India also that you will pay for the, airplane tickets based on your weight. So the whole ecosystem is going to change. So let's see some of the whatever we have talked. Let's say here is a patient, and the patient requires constantly monitoring his or her psychological status. So what is the doctors do or the nurses do? They sit there. One attendant is always there, and since the attendant is human, he or she is prone to the human factors of fatigue and monotony, all those things. Why can't we should have devices which will automatically send an alert instead of observation? Some of them are already there, but you can make it immediately. So today what happens, if you see some of the reading, you start calling the nurse, then the nurse call the doctor. We can automate it. Similarly, we can have implantable transceivers. So you can be at your home and there will be a concept of remote patient monitoring. This will reduce the cost, reduce the traffic, reduce the need of, number of beds. You can get those things. Most of the time, you do not need to go to the hospitals. So that is where the remote patient monitoring can be very helpful, especially for the old people. It's not very easy for them to travel, to transport. So that's where this will save time also. Then improved and timely care. So if you have patient health data, plus you can apply all the data analytics on that, and then you can get actionable insight. That means you can do some pre-analysis. You can prevent something from happening rather than let it happen and then we'll take the actions. The best part is, can we stop it? If somebody is going, today we have a concept of pre-diabetic. So why it has come? So stop people going to the diabetic stage. But then how many of us are getting it checked at the regular times? And diabetic is one huge area where a lot of research is going on. Even as far as I can remember, my friend Dilip ji is also doing some research on the diabetic and the effects it has on the body. So here we can use those AI, machine learning, data analytics, and we can prevent diseases from happening rather than curing it. Let's see one slide, how a small IoT deployment can impact the healthcare, save time.
नेटवर्क इशू सर, नेटवर्क इशू आई थिंक, वीडियो रुका हुआ है, डिस्कनेक्ट हो गया। जस्ट वेट 1 minute, between network issue there's lag, will come once again, we need to wait. What is time for 12? Okay, I think between network issue. Wait, sorry.
Yes, yes.
Yes, sir. Yes, sir. Just summarize, sir.
So, was the video over when I disconnected?
हाँ सर, वीडियो हम लोगों ने देखा, थोड़ा सा बाकी रहा लास्ट में.
Okay, not an issue. See, the evolution of medical sensors very important in our healthcare, the kind of sensors development which is taking place. So if you can see these sensors with ear, it is in this slide. So started with, the glucose analyzer in 1973 to the test strips we use today in 87 to glucose watch in 99. And now we have in 2012 tooth enamel biosensors, contact lens biosensor, which has went ahead up to sweat microfluidic biosensors, and the list is continuing day by day. So imagine these kind of sensors in use. These are when they have been developed, but now it is coming to the real use, and the costs are going down. The medical community is getting trained, and at the same time the computer science people with their analytical algorithms, with the AI and machine learnings, ready with those algorithms, those architecture which can bundle it all together, do the necessary coordination and come with some important analysis. So many of the young BTech, MTech people who are listening, you can have your projects, you can design some architectures based on the latest technologies available today, and even you can get funding. So the sensors for healthcare, if you divide, it can be divided into the physical sensors. The type may vary from radiation sensors to mechanical sensor to thermal sensor to magnetic sensors. This list is growing day by day to the chemical sensors with where you can detect ingredient and concentration of body liquids such as the pH value, the calcium ion concentration, glucose concentration. Then there are biosensors, the devices that combine biological material with a suitable platform for detection of organisms, toxic chemicals, etc. So the list is you can have many types of healthcare sensors available today. All we need is the right kind of architecture, the right kind of softwares, the right kind of devices where these can be put in regular use. This one device I wanted to show. So I have a small video at the later stage, but you can see monitoring glucose level is a very important for diabetic patient. And you just imagine 1 in 11 people in India is diabetic right now. 1 in 11, just imagine. And this is when we have not done the entire testing because of our poverty and all. Not everybody is being tested, but as per the data available, India has around 80 million diabetic people. And now you need to monitor blood, empty stomach, then after 2 hours after food. And the newer research says that it's not all. You need measurement at different time, and it's a very painful process, pricking the fingers. So can we do something about that? And here is our devices which can track glucose level continuously. Mind it, continuously for 14 days. So you have the 14 days data. What happens when you sleep? What happens when you get up? What happens when you are eating what? So in 14-day data, that means you know what you eat, which is increasing your glucose level. What is different people have different types of body. So one solution is not there for everyone. So today we are unable to know, but these kind of sensors are completely changing the way diabetic is looked and diabetic is being treated. Then there are smartwatch, So these kind of devices can monitor for 14 days. Once you have done the analysis, you don't need these kind of, because it's a bit costly. But you can have smartwatches. Already many of you might be using it. So those can monitor those things. If you can find a relationship between your, let's say, the heart rate and glucose level, then you can monitor one and know the other. If you can have some sort of relation between your blood pressure level and the sugar level, then you can know. You don't need to prick every time. So these kind of analytics is being done, and hopefully in future we will come up with many more. So as you can see, smart pill bottle and pouches, which will give you the necessary reminders. It will inform whether you have taken the dose when the bottle is opened or not, because in old age people forget, no, they take the same medicine twice. They forget whether they have taken or not taken. So it can prevent overdose. So you can see the diagram here, and we can design any of these things. Then just see this small video again, where you can see how monitoring is possible today.
Sarah can take her first glucose reading 1 hour after the sensor has been activated. If the reader is off, just press the blue home button to turn it on. It's the only button. All other actions are done on the touchscreen. Hold the reader within 1.5 inches of your sensor to scan it. You can scan right through your clothes. When you scan, the reader displays your current glucose reading and a glucose trend arrow, which tells you the direction your glucose is going and how quickly or slowly it's changing. The glucose graph will display the most current 8 hours of data. If Sarah taps the pencil icon, she can add notes about food, exercise, or an insulin dose. Instead of finger sticks, Sarah can now simply scan her sensor to get her glucose reading, plus a lot more information. You can do it without finger sticks.
So what we have today now we have a monitor which will give you vital sign, fall wandering. You can do. We have assistance in form of alarm, notification, graph. But the future will be more monitoring. The devices will be context-aware measurement, daily activities monitoring, social interactions monitoring, mood detection, depression detection, and you will get assistance in a more accurate way, simulated environments. Then the need of today is transdermal medication, because you need medicine in the right amount at the right time as needed. Not that some doctor fixes the one tablet in morning and one in the night, because your daily physical activity as well mental activity is varying. So your body requires different doses of medicine at different time. But today we are using it in a fixed manner because we do not have that data. But tomorrow in future we will have those data, and so we require transdermal medication, some strips fitted on your skin which will release medicine as required, whenever required. So this is the future, and those things are possible only with sensors and wearable. So I also got a paper, a 2018 survey, that what are the barriers for IoT adoption in healthcare. So just to put one slide. So it's not one way. I mean, you have your issues. So first is the users barrier. People may not want to constantly wear the IoT devices. So you need to, while design of the IoT devices, you need to take care that if somebody has to wear it 24 hours, it has to be lightweight, it has to be comfortable, require padding and all. So wear devices, they may wear devices incorrectly. The problem is if you wear it incorrectly, the data it will send may be not accurate, and you end up getting wrong medication. So we need to take care that the devices are weared properly. Then there are traditional barrier, like old people, have a habit of visiting doctors. So unless they visit a doctor, even if the same medicine you provide at home, there will be mental hiccups, he or she may not feel comfortable. Those are also an issue, and they may find it difficult to use which button and when. Then there are risk barriers. Healthcare data can be accessed by anyone on the cloud. You can hack somebody's data. So there are privacy issues, there are security issues. So there are certain bit of issues to be handled, some by the doctors, some by this privacy and security has to be handled by the computer science people. The design of wearables and all needs to be handled by our electronics friends, the electrical friends. So lots of engineering branches coming together with the medical community. And finally, you can have something worthwhile for the society. Now see this, This is a 2021 paper in Nature, a very reputed scientific journal, and I put it at the bottom. They are trying to now design a digital nervous system, completely like the actual nervous system. And they are already in the design stage. The work is already being done. So as you can see, there is a breathing and sweat sensor, then there is a pulse sensor, the motion sensors, and then there is a band-based unit put on the top of your hand, body area network, which controls all these devices. And then the actuator is somewhere in your brain, maybe transplanted or on top of it, and it can help and assist in decision making as our normal brains do. So this is the future. We are talking about, just imagine a person with disability in one part, but you can put in sensors, get data, and make those things working again. So people are working up to that level in the healthcare system. If we compare this, you see on the first column, it's a component, and then second is the attributes. The third is the biological nervous system, our present nervous system. And the fourth is our digital nervous system, which people are working on. And hopefully in near future, you will have a digital nervous system. So as you can see, the muscle extension contraction here, you can have muscle to sensor extension contraction. And similarly, the list is there, like sending up signals can be done using wireless electronic signals. So central nervous system can be, modeled like a cloud data handling system. So these things require better technologies, better wireless speeds, better hardwares, better and robust connections, and security and privacy at the same time. But these all are areas where we need to work. Just ending with this one small video. I think I'm reaching to the end of my time.
Yes, sir. Yes.
Yes, just 2 minutes. So just let them see the future of healthcare.
Yes.
In the decades ahead, healthcare will undergo dramatic transformations. Medicine will become more precise. Value will shape care delivery. Patients will become empowered consumers. And digitalization will transform every facet of healthcare. Patients will have a digital twin, a customized computational model of themselves, enabling Dr. Clive to anticipate illness, guide therapy options, and predict outcomes of procedures. Expanding precision medicine will enable radiologists to make highly specific diagnoses for Stephen without unwarranted variations. AI-powered decision models, fed by vast population health data, will improve diagnostic accuracy. Healthcare will become anticipatory, organized around Paula's medical conditions, and available around the clock, transforming care delivery. Multidisciplinary, highly productive care teams structured around patients and their needs will collaboratively deliver the full cycle of care. All interactions with John will become convenient, personalized, and compassionate, improving patient experience. Supported by real-time monitoring and guidance, John will become more empowered and have physical and virtual access to care when and where he needs it. At Siemens Healthineers, we are enabling healthcare providers to increase value, shaping the future of healthcare.
So some of the challenges, so I'm skipping this. Thank you. I think I'm already end of my time.
Yes, sir. Participants, if you are having any kind of question, you may ask them, sir. So please welcome. Is there any question? Yeah, ask.
Sir, how do you think that in India, with such a large population, can we implement this IoT and AI in India's healthcare system?
See, rather I will put it in a reverse way. India is the place where you need these systems because the ratio of doctors to the number of Indians, you know what is the situation. So we need
Yes, sir.
more of these devices because it will reduce cost. Once you start manufacturing in large way, the cost of these RFID tags and all it will reduce. And once that get reduced, you need less number of staff in the hospitals and better monitoring. So we need to come up with those kind of, we need more support from the funding agencies. Dilip sir will agree. I have also put a proposal to the government. If I get funding, we will start something in the IoT in healthcare. So those are, but it is required. I hope you agree.
Yes, sir. Thank you, sir.
Is there anyone?
Uh, Good afternoon, sir. Jayam Pandit. Thank your session. You explained very well. I have one question. You
Sure.
explained these things. These things seems complex to me. Could you suggest me one thing that is pretty easy and I can implement and directly help healthcare sector with IoT, with the knowledge I can gather?
So you are at what level of your study? I mean, BTech, MTech, PhD?
Sir, BTech first year.
BTech first year. So you catch the lip, sir, and start working first on the analytics part. So let's say, as I showed you, there is one device which give you the continuous reading of 15 days of a diabetic patient. So just imagine the amount of data you get. Okay. And if we can, the institute can provide you one of those devices. It's around 15,000 rupees only. And if you monitor the same patients, the other body parameters like blood pressure and all the weight and all those things, then you can find a relationship, do some analytics. Later stage, you think of developing your own IoT devices, because, that requires industrial support. You cannot do it in an institute lab. So first, the easier thing is you start using some of the devices and data analytics.
Okay, sir. Thank you, sir.
Okay, so I think, is there anyone more? No. Okay, so thank you so much, Dr. Prabhat Kumar sir, for your valuable time. Your expert talk has provided us with invaluable insights about history and evolution of IoT and its impact in today's growing world. The video you showed was quite visionary. You informed us about applications of IoT and very smart technology. Then you talked about problems in healthcare systems and how IoT can be used in improving those things through an amazing and informative video. I am sure our participants have attained a better understanding about all these topics. Thank you again, sir, for taking your valuable time to impart us with your knowledge. Thank you, sir.
Thank you, Bhai, and wishing lots of good wishes to all your participants. Thanks.
Thank you, sir.
Thank you, sir.
So please, what you all are doing? Actually, we are just monitoring. and based on attendance you are going to get certificate. So please take it as serious. That's why I'm telling. 80% attendance is compulsory, and some of them are leaving it. So please, those who are absent, if they are your friend, inform to them to join. So our next resource person is going to be joined.
Yeah, good afternoon, Dilip sir.
Yeah, yes, sir. Good afternoon, sir.
So
Thank you, sir, for
give me
it.
2 3 minutes.
Yes, sir.
Give me 2 3 minutes to set up my slides, huh? And
Yes,
then
yes, sir. Thank you, sir. So accepting our invitation, we are obliged for this. Sir, so we may start your introduction, sir. May we start?
yeah, maybe I will need 2 3 minutes before I begin. You may
Okay,
start.
sir. Okay, sir. You when you will start, sir, you will tell me, sir. Then I will start.
Sure, just a minute.
Sir, may I start?
Yes, you can start.
Yes, sir. Thank you, sir. Firstly, thank you, sir, for accepting our invitation. And we are highly obliged for this. On behalf of our institute, I cordially welcome you. Sir, we are honored to have you with us. So I will introduce about you, our research person. Dr. Rajiv Misra is a professor in the Department of Computer Science and Engineering at IIT Patna, India. He obtained his PhD degree from IIT Kharagpur, MTech degree in Computer Science and Engineering from the IIT Bombay, and BE in Computer Science from Manit Bhopal. His research interests span a design of distributed algorithm for mobile, ad hoc and sensor network, cloud computing, big data, and wireless network. He has authored a textbook on cloud and distributed system variant. He has offered online MOOC, NPTEL, SWAM in cloud and distributed computing, big data computing. Sir, it's an honorable moment for our institute to have your prestigious presence in today's event. We are truly inspired by your deeds. I hereby request you, sir, for enlighten our minds with your expert talk. Sir, please, you may proceed.
Thank you, Dr. Dilip, for this invitation. I think this is the first interaction with the IIIT Bhagalpur. So let me share my camera. So are the slides visible? Can you confirm?
Yes, sir. Your slide is visual, sir.
Okay. Is it coming in the full screen or?
No, no, sir. Not full screen.
Okay, then. Is it coming now? Full screen?
Sir, right now, not shared, sir.
Okay, not sure.
The screen have not shared.
Is it visible?
Yes, sir.
Okay. Okay, thank you.
Yes, sir.
Is it full? Yeah. Okay.
Yes, sir. Visible.
So let me thank the organizers for having this patience. Okay, over this medium that is online classes. So before I start, let me give you a brief introduction. That today's topic will be the artificial intelligence in the drug discovery and the development. So as this particular title of this seminar or a workshop. This particular field, that is AI and machine learning, that is covered under AI, and this particular healthcare. So I have chosen a different topic altogether. Maybe other speakers will not be delivering on it. So this is about the artificial intelligence, how that is used in the drug discovery and the development. So with this title, I am Dr. Rajiv Mishra, working as a professor in the Department of Computer Science at IIT Patna. So let me introduce more about me. Is that we have in IIT Patna the PhD program, MTech program, BTech program. So PhD program comes in different flavors. So regular and full time comes through this one with a scholarship from the institute side. Then you have the part time category, employed and part time category. That means you can be there wherever you are working, and yet you can do the PhD. We have few candidates working in this mode. So any one of you who is the MTech and want to pursue the PhD, there are two options for you. Either you can become the employed and part-time and enroll to us, or you can qualify JRF or UGC NET and secure your fellowship and get the admission easily in IIT Patna. So we have so far means my scholar. One of the scholars is working in this field, which I am going to present here, that is artificial intelligence in drug discovery. So this work we have started 2 years ago. And obviously we have done several publications in this area. So with that know-how, I am going to make you this presentation. So please interrupt me wherever you feel or you want to interact with me, or you want to ask questions, or you want to have some discussions. So it will be a quite interactive sessions. It's not that because this topic is quite different if you have a computer science background. And so let us get started with this. So this is a little introduction of the entire viewpoint which I am going to make here in this particular discussion. Is that that the drugs which comes in the form of the medicine to cure the diseases was quite stabilized prior to the COVID. And that these particular drugs were require, let us say that 14 years for one drug to come at the production level where the doctor prescribes and the disease is being cured. But novel coronavirus and the post-virus corona situation is quite different. So this virus attacks the humans, and that means you have to discover the drug. Not in that 14-year span, very quickly you have to do this. So this entire life cycle of drug discovery requires an automation, and not many experts are available. Therefore, the intervention of AI and deep learning becomes the rescue. So from 14 years of the drug discovery time, you have to reduce it to something like 21 days or 46 days. And therefore, these particular techniques which are available, which you are applying in other areas like in images, that is the deep learning, CNN-based models, or the generative adversarial networks, or reinforcement learning, or LSTM. All these different possibilities of deep learning model is together is used here for this rapid drug discovery. So this particular area of rapid drug discovery is being aided by this artificial intelligence. How that is all done, that we are going to discuss here in this particular part. So with this slide, we are introducing you about uh, about about the drug discovery, which is a mechanism in building up the medicine. So in the field of medicine, drug discovery is a process by which new candidate medications are discovered. So obviously, this you want to do in a speedy manner, unlike 14 years span, which was required earlier days. But now, every now and then, you are hearing about new coronavirus variant, and that requires the intervention in the form of drug discovery. So, finding out the new medication, new candidate medications to prevent the disease or to treat the disease becomes challenging. Now, so therefore, for a disease, if you see, what is required is the protein, which plays the crucial role. Although these are not my specialized areas, that is about the drugs and all that, but slowly we will move towards our intervention of AI and deep learning. But nevertheless, we have to deal with the domain. So I have to explain you very slowly all these concepts. So therefore, for a particular protein, we have to find out the binding pocket or the binding sites. So there in this particular figure, if you see, you have the protein target, and within the protein target, you have to find out the binding pocket, and this binding pocket has to be now filled with a candidate molecule. Okay, so now the candidate molecules are generated that can fit into the binding pocket in order to cure the disease. So you can ask this question yourself, that whenever there is a disease, so there will be a disruption or a break into the protein. So a healthy person has the proper protein structure, but when a disease is infected, or infected person will destroy this protein structure and will create these binding pockets. So to recover or to heal this particular protein, this is called protein target, and for that you require the candidate molecules, and this is what is required in the drug discovery. So that particular candidate molecule, which can heal this protein target, this is what is called the medicine, and you have to find out that candidate molecule to do this. Okay, so with this small introduction, I think if you have understood this concept, then rest of the things, rest of the slides will be easier for you to understand in this lecture. So therefore, what you want is have kind of you have to search, that is through these molecules, set of molecules. Set of molecules are many. It's not a few. If it is few, then it is the task is quite easy. So what you have to do is you have to find out, for a free target protein, you have to find out a particular molecule, and then you have to then make this understand the study about whether this particular molecule, when it interacts with this target protein, is active. Active means it is going to solve the problem of the disease, or it is inactive. So this particular figure shows that you have the target protein, and when you add a drug ligand that is called molecule, then whether it will fit into your, which I have said, that binding pocket or not, and cure that particular disease in hand. Therefore, drug is a small molecule that binds into the target into the target protein and modifies its function to produce the useful physiological or the mental effects. Now, the proteins are large biomolecules which consist of the chains of amino acid residues. Now, drug discovery in this entire process is the process through which the potential new medicines are identified. When you say medicines, that means you are talking about the molecules, which is also called as the drug. So potential new medicines are identified, and that is called the medicines. It involves a wide range of scientific disciplines, including biology, chemistry, and pharmacology. So this is going to be a little introduction, and with this, let us see what are the rational drug discovery process of finding the new medicines based on the knowledge of biological target. So they are most commonly an organic small molecule that activates or inhibits the function of a protein. That is what we have discussed in the previous slide. This is the second step. And the third step involves the design of molecules that are complementary in shape and charged to the biomolecular target. Now, with this to understanding, you have now being visualized that how this problem can be solved with the help of AI. So let us see and go ahead that in this drug discovery. So drug discovery timeline, as I told you, spans over 14 years earlier days. That is traditional drug discovery process is time consuming and expensive. Why? Because there exists a vast chemical space, and that is comprising of more than 10 raised power 60 molecules. So the number of molecules which are required to be checked for the target molecule is too much. So that optimizations also of interdependent properties has to be checked quickly to save this 14 years time. So this, that your artificial intelligence searching the solution space quickly is at the ease or expertise for it. So therefore, AI has the potential to accelerate this development timeline by generating the molecules in the desired chemical space. So these are different approaches for drug target identification, and we are talking about here only one approach, that is called computer-aided approach. So computer-aided drug design, that is also called CADD. So computer-aided drug design has two different ways of solving this particular problem. One is called structure-based drug design, SBDD, wherein you have to identify the binding site, and then you have to do the docking, means you have to embed the pocket with that molecule into the protein, target protein. This is docking and scoring. The second approach is ligand-based drug design. There you require a quantitative structure-activity relationship, QSAR, where some modeling is required, and then all this particular combination of identifying this particular drug design goes through screening and compound selection and lead optimization, and then lead to a new drug. So let us understand a little more on it from our computer science perspective. So, so when you see that the molecule is to be now have to be identified. So let us see the molecule. The number of molecules is in the range of 10 raised power 60, which we have seen in the previous slides. Again, I'm going back showing you 10 raised power 60 molecules, such a big list. So for this molecule generation methods, you require the representation of the molecules. So how do you represent the molecules into the computer? So just like you might have known that for a matrix, how do you represent the matrix into the computer? You have two representations. One is called adjacency list and the adjacency matrix. Similarly, the molecule is a structure. How do you represent? You have to represent into different classes. First one is called string-based approach. The other is called graph-based approach. Now, string-based approach of representing the molecules into the computer is that particular involves a encoding method that is called SMILES. So small sequence. So small sequence of the molecule as the input. So you might have seen this is the compound caffeine. It is having the molecular structure, molecular graph. If you have already done the chemistry course, you might be aware about such kind of structures, which you have already required to write in a practical notebooks of a particular notebooks. Now this is the molecular graph. Now this molecular graph can be represented in the form of a smile structure, which is shown over here. So this is one way called string-based approach, string-based method of representing the molecules. The second is graph-based approach. So graph-based approach means full molecular graph. The graph-based approach includes the method that takes the molecular graph of the molecules as the input. The entire structure goes as the input. Now there are two obviously ways of representing the molecule. So you may ask which of these two methods are good. So obviously when you are talking about the graph-based approach, that is the entire molecular graph, that will contains much more information, that is about the structure of the graph, structure of the molecule, also as the feature into the input. Obviously graph-based approach are more powerful, yet it is more difficult to be used in this particular process of AI over the string-based approaches. So string-based approaches that it incorporates the structural features of the molecule during the model training. So you might be knowing by now that that machine learning requires two-step process. First is that you require the input, and the input is given to the machine learning algorithm, and this machine learning algorithm takes the input and is called the model training. So this particular model training is done either with the help of strings or with the help of the graphs. So we are looking up in this another slide in more detail about that. So if you see from molecules, the different representations which are shown over here is that when you take the graph, then from the graph you generate the vector, and mostly these are discrete substructures which are coded. So you see that in computers, these vectors are easy to manipulate, and but not easy to reconstruct the graph from that vector, which is also called the fingerprints. But these vectors, you know, that are also sometimes called the tensors, and therefore are the elements which you can optimize or which you can compute into the deep learning models. So this is the molecule representation and how you are using it in the form of vectors called fingerprints. That is, the molecules are turned into the fingerprints. That is the graph which is converted into the vector, and the vector is the unit of the data or the input which is being used into the deep learning models. Now, molecule to the strings. So the molecules to the string conversion or encoding, as I told you, that they are also called the SMILES. The full form of SMILES is simplified molecular input line entry system. So you don't have to worry. Why? Because a lot of modules, a lot of libraries are available if you will work in this area. Like in the drug discovery and drug design, that particular libraries are taking this molecule as the input and automatically converts either the SMILE structure or a graph-based structure. So again, SMILES is the simplified molecular input line entry system. And this is ready for encoding, decoding with the sequential models. Okay, so but this particular strings, that is a SMILE string, is not the graph. So from the SMILE strings, you can convert the graph, which is not unique. Therefore, that means once you convert it, the molecules into the strings, so it may use the structure information. And that is what is being shown over here. So the methods which that is the machine learning methods which uses the strings and the methods which uses the graphs. So obviously graph methods which uses the graphs as the input are much more superior compared to the methods which uses the strings, that is the molecules which uses as input as the strings. But the molecules input as the string is simpler methods. But it is losing some of the information which is shown over here. We're not going into details. We are explaining you in a much simplified manner. So therefore, from molecules, if you want to convert into the graph, so there is no regular and fixed size structures, and the graph are permutation invariant. There are multiple objectives: that diversity of generated graph, smoothness of latent space, and agreement with or optimized of multiple drug-like objectives. So these are some of the objectives which depends upon your problem formulation, where which one is important. Then you have to decide whether you go for the graph, where it requires more complicated algorithms compared to the SMILE structures. So let us understand a simplified problem formulation and talk about these objectives. So let us see that you have the data set, molecular data set, which is called capital DG, and the underlying data distribution. And so this aim is to learn how to obtain the new samples from the data distribution by employing the deep generative model. So the objective here is to build the framework that can generate the highly potent active candidate molecule that can interact with the target protein structure with a high binding score. So the evaluation is done with a high binding score, and if it is active, then it will solve the problem, or it will cure the disease, which is nothing but the damaged protein that we have seen in the previous. So with this understanding, now we will show you that there are various data sets which are available for the molecule generation community. These are all named as Zinc, CamiBL, GDB, and GDB 17. And as far as the graph generation are concerned, so there are various graph representation. The simplest one is called single shot graph representation. So single shot graph generation is the idea of generating the graph in a single step. This is to be in contrast to iterative method to build the graph. So obviously this is a quick way of generating the graph structure out of this molecule. And there are various methods which are standardized as of now. MoIGAN and Graph NVP, and all these methods are available in the literature. We are not going in detail about them, but nevertheless, to make you excited about this particular concept, we will make you aware about this MOI-GAN. Is an implicit generative model for small molecular graphs. So you can see that in this MOI-GAN uses GAN is a generative adversarial network. So it is a type of deep learning model with a discriminator and generator together, which uses the molecules in the form of a picture, and which will use there to train this particular model. There are various other single shot graph generation, RVAE. This is another method. So graph NBP. This is all such methods for single shot. Now there are iterative graph generation model also. And so in this iterative graph generation, molecules are generated in a step-by-step manner by adding the components to an incomplete molecular graph, one step or the action at a time. So below we summarize few models here. They are shown as a graph invent, JTVAE, DeepMind, NVBAE, and so on. So all this, let us skip the details because you may not know, you may not be interested about that. So this is our paper, which is published in the network modeling analysis in healthcare informatics and bioinformatics. So the title of this particular paper is Generating Novel Molecule for Target Protein, that is SARS-CoV-2 using drug target interaction based on graph neural network. So this particular work is based on iterative graph generation that we have in the previous slide. We were talking about that. So there in this work, let us briefly summarize this, that in this our work, we have proposed a framework that takes the account of both tertiary and sequential representation of molecules and proteins using gated graph neural network, knowledge graph, and early fusion approach. So more details you can find inside this particular paper. In the sense, what we are telling you is that instead of SMILE sequence, we have taken up the entire graph as the input and try to use a neural network model which is taking the graph as the input, called gated graph neural network. And then out of that, we have built a knowledge graph. So knowledge graph is the complete representation of all the molecules, that the not selective molecules, and from there you can easily build the early fusion approach for the drug discovery. That is what we have done on the publication, and Amit Ranjan is my PhD student. So we have done this recently, the publication. Okay, so this particular work, there the generated molecules from GGNN are screened using the graph, the knowledge graph, to reduce the search space by discarding the non-binding molecules. So you can understand that the knowledge graph will contain that particular molecule which is having this binding molecules and therefore may be fed into the early fusion model. Then binding entity score of the generated molecule is predicted using the early fusion approach. And then we have shown that experimental results of our framework is valid, and unique molecules with a high accuracy is generated while preserving the chemical properties. Then we have shown the use of knowledge graph, and we claim that this entire generation of the data set of the molecules was reduced by roughly 96% while retaining more than 85% of the good binding desired molecules and the rejection of more than 99% of the molecules. So therefore, 10 to the raised power 60 was a quite big list, and out of that, 4% or 1% is only we have reduced it to be selected in the drug discovery using the knowledge graph. So obviously, we have shown that that is doable with the help of knowledge graph. So with this, let me stop at this point because and let us take the questions if you have any, because this particular topic is quite huge. So I haven't got more detail to show you here in this particular slide. Over to Dr. Dilip Kumar Chobe.
Thank you so much, Dr. Rajiv Mishra, sir. Okay, yes, sir. Thank you. Participants, if you are having any kind of questions, you may ask from sir. Please ask. If you
A
are
very,
having any
a very
question.
good evening, sir.
Yeah, please.
Sir, I want to ask what is the major difference and how is the major difference artificial intelligence is used to distinguish the cure between RNA virus and DNA viruses?
That is a kind of classification problem which you are talking about. So that means your task is a classifier, to build a classifier using the artificial intelligence, that is deep neural network, which can identify on a given input whether it is RNA virus or a DNA virus. Okay, so it's a binary classification problem. And for that, you have to train the model with all features which are present into that structure. And then once the model is trained, then once you give a new kind of input, then it will be able to classify it. I hope it is clear to you.
Okay.
Yeah, is there anyone?
Thank you, sir.
Welcome.
Anyone? No? Okay. So thank you so much, sir, for your valuable time. Your expert talk has provided us with invaluable insight about how deep learning models along with biological technology are used in rapid drug discovery. You also talked about computer-aided drug design and how molecular representation can be converted to a graph. You also informed about MOI GAN for single shot graph generation and about SARS code to target protein generation using graph neural network. I am sure our participants have attained a better understanding about all these topics. Thank you again, sir, for talking your valuable time to impart us with your knowledge. Thank you, sir.
Thank you so much, Dr. Dilip.
So we are going to end this session for today, and by tomorrow your lecture will be started by 2, okay? 2 o'clock. So today was hectic due to inaugural session, but by tomorrow you are going to feel comfort. Only 3 hours, 2 to 5:20, okay? Bye.
Okay, so
Yeah, you all have to be present. आप attendance दीजिए, कोई भी आ रहा है, 4-5 दिन का है, तो अच्छा है, अच्छा मैसेज नहीं जाता है, रजिस्ट्रेशन इतना है, अटेंडेंस आप जानते हैं, लाइसेंस आईडी से सब आ रहा है, 80% हमने अटेंडेंस बोला है. I have talked you have to give at least 80% attendance. Many are absent, and however we are having a participant more than 75, but only present 55. 20 are out. So please be present. Okay. Thank you. Neither if really it will go like that, so I need to take, I have to take some action. Okay. Thank you, everyone. You all may leave it. Thank you. By tomorrow.
thank you, sir.
Thank you, sir. Thank you,
I will
sir.
share link for tomorrow class by night. Okay, link will be shared by night for tomorrow class. Thank
Okay,
you.
sir.
Okay.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Okay.